Assalamu alaikum. Hello, everyone. Uh, Good day to you all. What you are seeing here is a T section. If you look at the T section, it is symmetrical along y-axis. Thus, if you are to cut this thing into two vertically, what you will have on the left side is going to be the same with what you are going to have on the right side. So since it is symmetrical, for us to find the moment of inertia or centroid or whatever, our focus will be on the y-axis since it is symmetrical along y-axis. That's where we are going to focus on. So once we determine the axis of symmetry, the next thing is to divide the section into regular shapes. We can divide it into rectangles. Okay, so once you determine the symmetrical axis, you can just divide it into part of a rectangle. So in this case, we name the first one, that's rectangle ABCD as the first rectangle and EFGH as the second rectangle. After that, you can go ahead and calculate the area of the individual parts. Okay, so A1 is the area of rectangle ABCD and A2 is the area of rectangle EFGH. So we know the formula for area. For a rectangle, we know it is length times breadth. You multiply the length of this with the breadth. It is width and thickness. Okay, so you multiply it, that's B and H. So the 12 centimeter, which is the length, is the B, and the 3 centimeter, which is the thickness, is the H. Okay, so you can either use B and H or you can use L and V. I use L and B here. So I have 12 times 3, which is 36 centimeters square. And the second one, I have 3 times 10, which is 30 centimeters square. So after this, then you need to identify the axis of reference. As I mentioned in class during our lectures, I said that when you are considering the vertical, that's the YY axis, the bottom line is the axis of reference. So in this case, the line GH is our axis of reference. As you can see, it is written on the screen. So the line GH is the axis of reference. So from this axis of reference, you calculate your Y. And we know that the Y is the distance from the axis of reference to the centroid of that particular shape you are considering. So in this case, when we are considering rectangle EFGH, that's Y2 since we name it the second one. So the Y2 will be from line GH to half of it. We know that for plane figures, the centroid is always at the half of a rectangle. Okay, so Y1 is going to be the distance from GH of the centroid of rectangle 1, and the distance from line GH to line EF is 10 centimeter. So we can add 10 centimeter to the centroid of rectangle 1, and rectangle 1 is 3 cm, so the centroid is going to be half of 3 cm, which is 1.5 centimeter. So when you add 10 and 1.5, you have 11.5 centimeter as the centroid, as the distance from the reference axis to the centroid. Then for Y2, see the same reference axis. So when Y2 is going to be half of rectangle EFGH. That's 10/2, which is 5 centimeter. So after this, you apply the centroid formula, and the centroid formula says summations of product of area and the distance from the reference axis, distance of centroid from the reference axis over summation of all areas. That's summation of AY over summation of A. So we have our A, we have our Y. You can just substitute and solve for Y bar, which is the centroid of this T section. The Y bar stands for the centroid of the whole section. That's the T section. Okay? So the summation of AY is equivalent to A1 times Y1 plus A2 times Y2, all over A1 plus A2. So when you substitute the values here, that's 36 times 11.5 plus 30 times 5 centimeter. So all over 36 plus 30. You can punch your calculator and get the answers once, or you can do it one by one. So here we have 414 plus 150 all over 66. For adding and dividing everything, I got 8.54 centimeter as the centroid of this particular T section. So the next one is a C section or channel section. So this is the section. You see the dimensions. We have 80 cm, 250 cm, and 10 cm. The first thing always is to check whether it is symmetry along x-axis or y-y axis. So in this case, when you cut this thing into a long vertical, what you're going to have on the left side is not going to be the same with what you will have on the right side. So definitely it is not symmetrical along y-y axis. But when you cut it on the horizontal, what you're going to have at the top is exactly the same with what you're going to have at the bottom of the section line. So this shows that this channel section is symmetrical along x axis. So the next thing is to split it into parts. Okay, you can do it this way, the way I did it, or you can choose to do it other way around, whatever way we choose. The most important thing is to take note of the dimensions. Okay, so we have rectangle 1, 2, 3 now. The first one is rectangle ABCD, then DEFG, then GHJK, the third one. The area for the first rectangle is going to be area of ABCD, and the second rectangle is going to be area of DEGFG, and the third rectangle is going to be GHJK. So we use the formula for area of rectangle, which is base times height or length times breadth. So in this case we have 80 times 10, which is 800 centimeters square. That's the area of the first rectangle. And in the second rectangle, let's look at the third, which is the same. The third has the same dimension with the second. So the second one, since we divided the section this way, so you have to subtract that thickness, the 10 cm at the top and 10 cm at the bottom. Okay, so when you subtract 20 from 250, you have 230. So 230 times the base, which is 10, is going to be 2,300 centimeters square. So this is the area of the three parts of the section. The next thing is to determine the axis of reference. Okay, so in this case, since it is about the centroid is along x-axis, so we are not starting from bottom now. The axis of reference is going to be the first line from left. Okay, and in this case it is the line AK. So you are starting from left to right. So starting from left for y1, this is a mistake, it's supposed to be x1. So we have 80 over 2, because that from A to B is 80 centimeters. So you are starting from A to B, see, AD to BC, so which is 80 over 2, we have 40 centimeters. Then from Y2, which is the rectangle DEGF, it is only 10 cm, so you divide the 10 by 2. Okay, then for the third one is the same thing as the first one. So this is the values of x, that's the distance of centroid from the reference axis. So we have 45 and 40. So after this, you substitute everything into this formula, which is xy is equal to summation of ax over aa, so which is equal to a1 x1 plus a2 x2 plus a3 x3. A1 is 800, x1 is 40, A2 is 2,300, x2 is 5, A3 is 800, x3 is 40 also. So you add everything. After adding everything, we now have okay. I was trying to show you how to use calculator to get the values correctly, but unfortunately the camera is not capturing the calculator very well. But you can see that I put everything here because the calculator understands both mass, so it knows that it has to do multiplication before addition. So once you put everything in the calculator, you're going to get your answer. So you can do the same thing for the denominator also. So at the end of everything, I have 19.36 centimeter as the centroid of this particular channel or C-section. So I was trying to show you an alternative way of doing this. You can put everything in brackets, and like you put the numerator in bracket, everything. Then you put division sign and put the denominators in bracket also. So once you click on answer, you see that you will have your answer directly without the need to separate it or do it twice, without the need to calculate for the numerator first and then calculate for the denominator and divide the two answers.